Welcome. Hello and welcome everyone to the AWS Special Edition. Very excited to have you all here. My name is Peter Hansens from the Online Data Engineering Meetup, and I'd like to welcome you all and thank Syed and Chris and the rest of the team at AWS for putting this together, as I think it is very educational and we will get a lot of value out of it. Do feel free to reach out if you have any feedback on the event. Next slide. Yeah. Cool. So I'd also like to take this opportunity to let you know that we have an awesome data engineering conference, DataEngBytes, that we are running in August. Our CFP is still open and tickets are free. Looking forward to seeing you all there. Slide. And also to thank all of our awesome sponsors, including AWS. So thank you so much. Over to you, Chris.
I'm on mute. Yeah. So there you know I'm it's a bit of an experiment. So anyway, as I was saying, thanks, Peter. We're really excited to be a part of the Sydney data engineering community, and we've done a few events as part of this. So on Friday, we ran an event. We called it the Lake Formation Boot Camp, and thank you for those who actually attended. We had nearly 70 people spent 3 hours building out a data lake and doing some pretty cool stuff with it. So if you didn't get a chance to do the boot camp and you'd like to do it yourself, screenshot what you can see right now, because the URL here points you to a blog post that Syed Jaffrey, one of the SAs on my team here in Sydney, he wrote a blog post, and it actually goes through step by step everything we did in the workshop. Now, the approximate cost for doing that is about $30, but the good news is that if you hang around to the end of the meetup tonight, we actually do have credit codes that we're going to give you once you provide your feedback on the talks tonight. So we'll give you the credit code and you'll be able to do the workshop at no cost to yourself. So our agenda for the night. We're going to have 3 amazing speakers for you. My name is Chris. I'm a solutions architect manager here at AWS. All of the other speakers are solutions architects as well. So first up, we've got Masudur Rahaman Sayem, who used to be on my team. We always love Sayem. Tom McMeekin and Melody Yang, all of whom are specialist data analytics solutions architects. And so our agenda for the night is going to be, our first talk is going to be kicking off in just a few minutes here. Sayem is going to be taking you through real-time analytics on AWS with Apache Kafka and Flink. Then Tom is going to be taking you through Amazon Athena federated queries. And lastly, Melody is going to be talking about self-service ETL, leveraging AWS Service Catalog, ECS, and ARC framework. So that is what you have ahead of you tonight. Now, one thing to mention, questions. You should have in GoToWebinar, in that panel down the side, a panel that says questions. And this is where, if you have questions, please put them in there. As the speakers are talking, I'm going to be keeping an eye on that. And if we have time between the talks, I will pick out some of those questions and put them to the speakers. So if you come up with one while they're talking, put it in the questions box and we'll get to it. And so without further ado, I'm going to bring up our first speaker. I'm going to ask Sayem, as we call him, to take control and talk you through real-time analytics on AWS, an overview of Apache Kafka and Flink. Over to you, Sayem.
Thank you, Chris. Hi, guys. Let me share my screen first, then we can start talking. I hope everybody can see my screen.
Yes, we can.
Perfect. So let me enable my video as well. Just a minute. Okay. Hello, everyone. Thanks for joining today. My name is Sayem, as Chris mentioned earlier. Today, in this presentation, I'm going to talk about Apache Kafka and Flink running on AWS. So before I talk about these 2 components I mentioned, is Apache Kafka and Flink, I also want to give a brief idea about how you can start building your real-time analytics platform. On a high level, you can think of 5 different components you need to take care of. The first thing is about your sources. So of course, for example, let's say you can have various different data sources, clickstream data, IoT data, or data coming from various different microservices that you're building and talking with each other, right? And the next part is you choose your streaming ingestion tools. It could be a framework, it could be a tool available, and then you use that tool to push data to your streaming storage. And in the streaming storage, one of the common standard we see in the market is it comes up with high durability, high availability. It's elastic so that you can scale as required, and also it give you some more capability. For example, like replaying your ingestion logs that you're sending to your streaming pipeline, and also it comes up with default retention as well, data retention as well. And then the fourth part is, which is also very interesting, is stream processing. Now your data is in your distributed streaming storage, and then you will use various different tools and framework again to process those data, where maybe you will do some simple processing, or you might do some complex stateful processing as well. And finally, you might send it to different destination. It could be your transactional system running on a relational database or NoSQL, or it could be a data lake where you will run batch analytics on top of massive amount of data, right? So for today's discussion, or for today's session, I want to focus heavily on 2 components. Here, one is streaming storage on Apache Kafka, and another one is stream processing with Apache Flink. So first, I want to give some overview about Apache Kafka. Usually in this in data engineering series, I observe many people are well aware of Apache Kafka, but just to set the level for everybody, I want to give a brief overview of Apache Kafka first before talking about other offering we have on managed services. So if you think about on a high level, Apache Kafka at its core, it's another distributed database. That's how I can think of, where you can build a central nervous system for your infrastructure to ingest data from various different sources at a very high throughput, right? It could be IoT data, it could be data coming from your social media sites, it could be data coming from your data center as well, where you're running various different hardware. And then on the right-hand side, you have consumer, which is consuming data based on their requirement, based on their complexity of accessing those data and processing those data. Now, at its core, when I talk about Apache Kafka, if you can think of which is very common to other distributed database or other distributed engine as well, at its core, you can think of it's a cluster-based deployment where you can have many broker, or think about many compute node working together to serve a specific purpose, right? So as a standard or the best practice, you will have an odd number of broker on a Kafka deployment environment, and where broker will store your data. So when you create a topic, you specify how you will replicate the topic across multiple broker, and then based on that, it will replicate that topic data to multiple broker. And then you have producer, and then you also have consumer. So the way I think I consider producer and consumer is actually in every database component you can think of, you have a reader, you have a writer. So producer is actually your writer, which is writing to your Kafka cluster, and then consumer is your reader, which is reading from your Kafka cluster. And then also there is one more component we have in Apache Kafka, which is Apache Zookeeper, which at the moment do on a high level, it does actually various different control plane operation for Kafka. For example, monitoring broker, monitoring topic, monitoring partition. And I think many of you well aware of it as well. There is a project going on to remove Apache Kafka dependency, Zookeeper dependency from Kafka as well. Now, how write works? If you can think of when you're writing to Kafka, you are writing to a specific partition, and when you are writing to a partition, you are actually writing to the master node of that partition. So you have leader, you have a follower node. So since this is a distributed system and it replicates data across multiple nodes, so the way it works is you have a leader node and then you have a follower node. And let's say in this example, you have 3 partitions for a topic. So when you're writing using our API, then you're writing to a specific partition, and then it also maintains strict ordering when you are writing. And it also depends on whether it will maintain the strict ordering or not based on how you are writing. So for example, if you specify a partition key, Kafka guarantees that it will go to the same partition all the time, and it will maintain that strict ordering. Otherwise, you can also choose partition key randomly or choose a partition randomly. So it means you'll not get that ordering guarantee, which might be required for many applications. And then when you are reading from Kafka topic, you can read in parallel from multiple topic, from multiple partition within the same topic. So the way it works, all those threads that you're running will work within a consumer group. So, and also Kafka maintain the checkpointing for you automatically. So it means if there is any failure on the consumer thread as well, it can restart, or it can spin up a new thread, and it knows how far it has processed, and then it will start reading from the next record from there. So it calls consumer offset. It maintained that there. So that's how, on a high level, you can think of how read works and how write works in Kafka. Now, when you are managing Kafka by your own, of course, if you want to deploy a Kafka in your laptop, I think you can do it within a couple of minutes actually, and then start consuming it. But if you are maintaining it, or if you are configuring it for your production environment, it's very hard to set up. Many cases, it's really hard to scale as well. And the open source Kafka project don't have out-of-the-box console or metric visibility. And not only that, it also required a specific skill to maintain the infrastructure, such distributed infrastructure, which is also very complex to do. And that's how Amazon MSK, which is a fully managed, highly available, and secure Kafka service, can help you, where you can let the service handle all those critical aspects of distributed system, and then you build feature on top of it. So what does it mean? It means it will help you to make it accessible for your organization from the console. Within couple of clicks, within couple of minutes, you can build a new cluster and then start using that. Instead of you do the patch management, you do the scaling by yourself. Here are some of the highlights that's so you can think of when you migrate from, let's say, on-premises or self-managed Kafka cluster on EC2 to Amazon MSK, which means after migrating to Amazon MSK, you can free up yourself from ensuring or doing all those administrative work like patch management, operating system upgrade, operating system installation, hardware maintenance, and so on. Of course, for scaling, I will explain a bit more about how the scaling works in Amazon MSK. In terms of scaling, you can scale out your cluster in Amazon MSK, which means you can add more broker. But again, those who are aware of the way Kafka works, so when you create a partition, you specify how many partition you will have on a single topic. So let's say, for example, you created a cluster with 3 broker, and now you want to scale your broker Kafka cluster, and you added 3 more broker. So Kafka will not automatically start consuming additional 3 broker that you have added for your existing topic. So again, you have to do that partition remapping. So that's the work you have to do when you scale out your cluster on MSK. And then the next thing is for scale up storage, which is you can add additional capacity on your existing node, and it will not affect your availability of the broker that you are using on that time. You can do it on the fly. In terms of encryption, Amazon MSK support encryption at rest and encryption in transit as well. For at rest encryption, it supports AWS managed key, or you can use your own CMK as well to encrypt at rest. For transit, it supports TLS encryption. Now, MSK also has a deep integration with various different services. For example, if you are doing stream processing with Apache Flink, which I will talk more in today's discussion, is you can use Kinesis data analytics for Flink and then integrate with Amazon MSK. Not only with Amazon MSK, you can also integrate it with your self-managed Kafka running in on-prem or in the cloud as well. Then next thing is also building feature on top of your existing transactional system. So you're running a transactional database, a relational database, then you can use a database migration service or DMS to replicate change data or CDC from your transactional system to Apache Kafka without writing any code. And then, of course, for TLS authentication, it has integration with Certificate Manager. You'll also get integration with AWS IAM for control plane operation. For example, it's not a control plane operation for Kafka, it's a control plane operation for MSK. For example, create a new cluster, adding a new broker, expanding their storage. So all those operation when you are doing with the MSK API, then you can restrict those access with IAM as well. Then you can also encrypt your volume with KMS, which I discussed earlier. You can use CloudFormation to provision your cluster. We also integrate with CloudWatch, which means you will get metrics visibility with CloudWatch. You can also log your API call, especially the control plane API call with CrowdTrail. And then also MSK integrate with your VPC, so you can isolate your environment instead of opening it for the world. When I say about monitoring, MSK not only support CloudWatch monitoring. For example, in CloudWatch, you can do per broker or per topic level monitoring, but you can also use a very well-known open source monitoring tool like Prometheus, which will also help you to integrate with some other third-party monitoring tool, for example, like Datadog, New Relic, or Sumo Logic. If you are using those tools already, then you can also integrate MSK with those tools. Then for broker log, you can offload those broker log to Amazon S3 or Elasticsearch or CloudWatch. So instead of you writing code, you can just ingest data, push those data to Kinesis Data Firehose, and then Kinesis Data Firehose can push it to Elasticsearch if you want to do search on top of your broker logs. So some of the key feature to highlight, I mentioned earlier as well, to reiterate on that, when you're using Amazon MSK, Amazon MSK will take care of provisioning your broker and storage. At the moment, it supports M5 family and T3 family instance for broker deployment. Also, it will provide you 60 terabytes of storage for every broker. So it's not limited to the cluster, it's limited to a specific broker. And then currently we support 4 different versions. The recent one we support is 2.4.1. You can use Management Console, you can use AWS IoT API to provision your cluster, to manage your cluster. It means you can, anytime you can create a cluster, you can tear down your cluster when you don't need it. And it's fully compatible with open source Apache Kafka toolset and frameworks, as long as they are using the standard libraries and APIs from Kafka. It's provide encryption at rest and in transit, and has integration with CloudWatch, as I mentioned earlier. Now, also you can scale up your broker storage without affecting broker availability. You can also push custom configuration. For example, like many times you don't want to want your Kafka topic to be created automatically, so you can restrict those by pushing that custom configuration. Not only that, we also support 2AZ deployment. So as a best practice, well, I always tell my customer is to deploy in an odd number, especially like at least deploying 3 broker in 3 availability zone. But sometimes maybe you're running a test environment and you don't want to provision it across 3 AZ. So in that case, you can also provision it across 2 AZ. In terms of scaling out with your additional broker, you can do it without affecting the availability of your cluster. And Zookeeper, which I mentioned earlier, there is no additional cost for Zookeeper. It's already there. When you create a cluster, MSK will create it automatically on your behalf, and then we will manage that for you. And there is no additional cost for that. MSK also has various different compliance certifications like HIPAA, PCI, ISO, and SOC. And at the moment, it provides 99.9% availability. You can also do tag-based authentication for many environments. Maybe all those control plane operation restrictions that you are building, you are applying with tag. So that's what you can do with that as well. And also we support in-place version upgrade. So you can do rolling version upgrade to a different version or to a newer version if you want to do it on your existing Kafka cluster. It provides 40% lower cost comparing to self-managed Kafka cluster. And for many use cases, especially as I mentioned earlier, for test use cases, if you just provision with T3 family broker, it will cost you around $2.5 a day, which is very cost effective, I believe. And there is no additional data transfer fee within the cluster when you're deploying it in across multiple availability zone. And for Zookeeper node as well, there is no additional cost for it. Now, if you're using MSK, I would highly encourage to look into that link for sizing your cluster correctly. So there is a guideline available. Have a look on that, and it will give you really good estimation how many broker you need, what are the sizes of the broker you need, and what is the storage that you have to provision for your Kafka cluster. Internally, the way it works, when you create a MSK cluster, it runs on AWS managed VPC, and then behind the scene, we create a network connectivity within your nominated VPC, because when you create a MSK cluster, you will specify what is the VPC that from where you want to access it. So we will create that network connectivity within your VPC. And then for Zookeeper, again, it's under the hood. We maintain the availability and scalability of it, and it's fully managed. You don't need to manage it by yourself. It's one-to-one mapping between the Zookeeper deployment and also your MSK. So it means if you have 2 Kafka cluster running, it will have completely separate Zookeeper running for each cluster. That's very interesting for many of our customers. Like we released that service for around 1.5 years back, if I'm calculating correctly. So within that time, we released around more than 42 plus services on Amazon MSK, which is really awesome, I believe. So we are continue listening to our customer and adding more and more feature on Amazon MSK. So that's about streaming storage, how you can use Apache Kafka on Amazon MSK, what are the features available, how you can use it. Now I want to talk a bit further on stream processing as well. In stream processing, interestingly, there is so many different components available. For streaming storage, I think for many of our customers, it's very easy to choose from. For example, like two very popular stream storage platform is Kinesis Data Stream and Apache Kafka. For stream processing, there's so many different ways you can do, especially in Kafka world as well. You can use various different tools. Not only that, for example, like you can use Spark streaming, you can also use Apache Flink. So for today's discussion, I will focus on one specific tool, which is very popular. But I also want to highlight a bit more about what I see in the market. So like for stream processing, you can use Kafka Connect, for example, Kafka Stream, Spark Streaming, Apache Storm, KSQL DB, Apache Flink, so many tools available. And all those tools have some unique characteristics and unique power as well when they do that stream processing. So for today's talk, let's focus on Apache Flink. So what is Apache Flink? So Apache Flink is one of the popular stream processing framework, open source framework, which comes up with high-level API for example, like SQL and table API. It supports stream processing and batch processing. You can run very complex stateful operation on Apache Flink as well when you are doing stream processing. It has a simple programming interface. You can write your code in Java, Python, or SQL for stream processing, and it's very high performant. It does in-memory computation with very low latency. It provides high throughput, and it can handle very large state, which is also sometimes very important when you are doing stateful stream processing on your streaming environment. It could be Apache Kafka, or it could be Kinesis Data Stream. And also it supports exactly one semantics, which sometimes very important for many of the complex stream processing. Flink also comes up with various different operator, more than 25 plus operator. Like you can do basic transformation when you are doing stream processing, like filtering, map, and so on. You can also do complex analytics and aggregation. For example, like you can apply windowing function. You can do aggregation like sign, minimum, max, and so on. And then also you can join multiple stream together within Flink application. But again, Flink is yet another distributed component, distributed framework. You can run Flink in, for example, in well-known container management services like Apache Mesos, Apache Yarn, or Kubernetes. But maintaining the state of it, maintaining the availability of it, or scaling Flink based on the incoming data on your Kafka cluster, it sometimes is very hard and challenging. So that's where Kinesis Data Firehose, Kinesis Data Analytics with Flink can help you. It means the way it solves that problem is you build your application in Java with your preferred IDE using Apache Flink framework, and then you upload the jar file in Kinesis Data Analytics. So behind the scene, the Kinesis Data Analytics will deploy the Flink environment for you, and then it will run it for you. It also comes up with various different integration with well-known services. It's not only limited to AWS services, but also with open source, various different open source services as well. For example, Flink as a source, it supports Kinesis Data Stream, Apache Kafka, RabbitMQ, and then as a destination, after doing stream processing, you can send data to Kinesis Data Stream, Kinesis Data Firehose, Amazon DynamoDB, S3, Elasticsearch, Kafka, Cassandra, RabbitMQ, and many other services. So here's an example how it works when you are using Flink on Kinesis Data Analytics. So in this example, you have your sources, Amazon MSK or Kafka running in Amazon MSK as a source, and then you are applying some windowing and you are doing some filtering and sending it to different destination like Amazon S3 and Amazon DynamoDB. And behind the scene, you are using Flink running on Kinesis Data Analytics for doing that stream processing. So what Kinesis Analytics, Data Analytics, or KDA does for you, it means you upload your jar file, and then you can manage the application lifecycle with the KDA API. Like you create your application, you start your application, you update your application, or stop that application if you are not using it anymore. And it's instead of you provision the cluster, you let KDA to manage your environment, Flink environment, and it support auto scaling as well. So it means you pay only for what you're using, and also it follow all those design best practices when it is deploying your Flink environment or Flink application to KDA. It also provide capability like monitoring, and also can handle failure automatically on your behalf by checkpointing the state of your Flink application. And also, we are also committed to improve the open source Apache Flink project. Now, for today's demo, today I want to show you how you can do some stream processing with Kinesis Data Analytics running Flink with Amazon Managed Streaming Service, or MSK. Let me check. I have 20 more minutes to finish that. Hopefully we'll be able to finish it. So those who want to try by yourself after our session today, you can also try it from this GitHub link. But let me switch to, let me just close my presentation and switch to my desktop. Okay. So what I will do is I have already given the instruction here in my GitHub link, how you can do it. So first thing is, when you are building a Flink application, there are some housekeeping you have to do. There are some pre-configuration you have to do on your environment. The best thing would be to you should use, my recommendation would be to use a GUI-based interface, like maybe in Windows or maybe in Mac. So what I'm doing here is, first, I'm configuring a Windows machine and deploying various different tools. For example, like AWS CLI I configured. I've installed Git so that I can copy my project from here, and then I downloaded IntelliJ if I want to see the code and change my code. And also I have downloaded Apache Maven so I can compile my code. It's very important, especially those who are new to Apache Maven. So configuring environment variable is very important. Otherwise, it will be very hard when you are trying to compile your code. So first thing I would do is I will create a Kafka cluster, on Amazon MSK, and then we will go from there. So for creating a Kafka cluster, of course, you can do it by yourself from console, but instead of using console, because we have some configuration I will specify. So what I will do is I will do it from command line. So my Kafka cluster will be, let's say, Meetup 3. And here, as you can see, you can follow the documentation I specified in GitHub, but we don't need to change anything here. So what I'm doing is I'm using a specific role. Sorry, not this one. Just a minute. Create MSK. Yep. So that's the JSON file.
Can you make the text a little bit bigger? A few people are asking.
Yep. Just a minute. Okay, I think it's visible for you guys now. So what I'm doing is I'm creating a cluster called Meetup Demo 4. what I'm saying is I will use Kafka version 2.2.1, and then I will deploy 3 broker, and this is my security group configuration where I will deploy it. And you will find the same instruction in the GitHub link as well if you want to follow that. So what I will do is I will go to the path where I have that file. I think, let me just increase the size as well. Just a minute. Chris, can you tell me whether this screen is visible? Is it clear?
It could be a little bit bigger, maybe. And
Okay.
you've got 10 minutes left, Sayem. You've got 10 minutes.
Yep. Okay. Let me just do it. So what I'm doing is I'm creating a cluster, with this command where I already showed you the configuration of my cluster. Let me just copy it. Okay. So if it is running correctly, just a minute, let me just save it. Meetup demo 5, and I will run it again. Okay, so it's now creating a new cluster. For the test, what I will do is I will use the existing cluster, but I will show you that it has been created. But let's move on for that. So the next part is I have to deploy or compile my Flink application to compile the jar file. So what you can do, you can copy this project from my GitHub repo, and I have it here. So this is my Kafka app. In the target, I will just delete everything so that I can compile again, and you can see that jar has been created. Usually you don't need to do anything. I will also show you the code, what is the code written on that for that application. But for the time being, what I will do is let me compile this application first. It should return build successful information, which means it has been compiled successfully, and it will show you, it will provide you a jar file as output. While it is doing it, let me show you the code, what I have written. So the code is very simple. I have not done any complex system processing. So what it is doing, it is reading the property information from KDE application. What is the source, Kafka source, what is the topic, and then it is listening to the topic, listening from a source topic and sending it to a destination topic. It's just copying from one topic to another. But I think you will get it that how you can use Flink, and then you can also apply your complex system processing logic when you are using that application. So okay, I can see build has been successful. So if I go to the target folder, I should be able to see this file, jar file. So as a next step, what you will do, you upload the jar file in Amazon S3 bucket. So for me, it's already there. Let me show you my S3 link. And then Meetup demo. So that's the file I'm using. So what I will do is it has been compiled, and now I will deploy my application. So to deploy that application, so that's the configuration you will use. So you will create a Meetup demo. So my Meetup demo is Meetup demo 4. And what I will do is I will change some of the configuration here. Just a minute. So on this file, what I will change is I will change some of the configuration like bootstrap server, which I have created already. So my Bootstrap server will be the cluster that I have created. So at the moment, if you see my Meetup demo 5 is creating, but for the test, I will just use Meetup demo 3, and I will just copy the broker configuration. So for this, I need this broker configuration, TLS configuration. So I will copy this configuration and then I will paste it here. And I'll do the same thing here. So that's what we are specifying, what is my source and what is my sink. And for source topic, let's say my source topic is, I will create a topic which is 4, and this also is 4. Destination topic will be 4. So I'm good to go to create my KDE application. So for that, what I will do is I will run this command to create my KDE application. So let me switch to this path. And then I will run this command. So what it will do, if I run this command, it will create a KDE application called Meetup Demo 4. If I have time, I will explain as well that what we are doing here, but let me finish that demo first, then I will explain what I'm doing here. Apart from this configuration.
5-minute warning.
Yeah, so as you can see, it has been created, the application. The next thing is I have to start my application. So to start that application, again, I'm using this configuration, and I will start my application. Perfect. So I should be able to see my application is starting. Let me go to Kinesis. And then if I go data analytics, I should be able to see the new application. So Meetup Demo 4, it's starting. And usually, if it starts successfully, you will see a graphical diagram here. So while it is starting, what I will do, I will go to my Linux machine, which I have configured earlier, to connect with my Kafka cluster that I've created recently, and I will create 2 topics. So for that one, what I will do is I will take the Zookeeper configuration from my Kafka cluster, so I can connect with the cluster. So this is my Zookeeper configuration. I will just say so as a shortcut, you don't need to do it, but instead of you typing again and again, so I add it in the environment variable. And then what I will do, I will create 2 topics. My topic is, it will be, I think, source topic 4. Source topic 4. Let me check my configuration on the KDE, what I'm doing here. So if I go here, if I see, so source topic 4, yes. So source topic 4, I've created. So I've created a topic in Kafka called source topic 4, and then I will create a topic called destination topic 4. I'm nearly done, Chris. Maybe I need 2 additional minutes, but I'm nearly done. Okay, so I've created 2 topics. Just to confirm whether it has created my topic or not, I will just list those topics in my MSK cluster that I've created. So I should be able to see 3 topics. Yes, so I created 2 topics, and one is system topic, which is for consumer offset. So I have 3 topics now. So what I will do, I will keep listening on the destination topic. I will tell you why I'm doing it. First, I will again take the bootstrap configuration for my Kafka cluster so that I can start using, I can start listening to that. So I've copied the bootstrap configuration and I will export that. Boot server equal to this. Perfect. Now what I will do is I will start listening to my destination topic and see whether it is showing me any message. Usually you should not show any message on the destination topic because I have not started ingesting anything to source topic 4. So as you can see, it's doing nothing. During that time, I need 2 more minutes, Chris, but I'm nearly done. Let me check whether my application is working. It started or not. Let me refresh my window. Awesome. So my application is running. I'm good to go. So what I will do is I will start ingesting data to my source topic at the moment. So for that, I have written a Java application here, and which will start ingesting data to my source topic. I just need to change my broker information 9092. Let me just go to this 9092. I copied this. I paste it here. Perfect. Let me run my application. So as you can see, before running it, so there is nothing coming here, but if as soon as I start running this application, I should be able to see my Java application will start sending data to source topic, and then my KDA will start, Kinesis Data Analytics will start consuming from my source topic and send it to my destination. So this one is actually done by my KDA application. So if I go to my Kinesis Data Analytics console, I should be able to see some metrics actually that it has started initiating, and then it's just keep listening and doing all this work. That's fantastic. So that's about the demo about, sorry, I quickly shown that because we don't have much time, but the demo is about you are ingesting to a topic, and then you are using Apache Flink framework to process those data and then sending it to various different destinations. So it doesn't mean that you just need to use Kafka. You can now write your own logic, write your own code to send it to various different sync. Like you can push it to S3, you can push it to Elasticsearch as well. It's up to you the way you want to do. Now, some of the thing about Kinesis Analytics, you can also create your application from the console instead of using the CLI that I've shown you earlier. And you can also provide all those runtime parameter. So that's where the GitHub link that I shown you earlier will help you to learn more, and then how you can use that by your own actually. So that's it for the demo. I don't have anything more on this for the demo, but I can take some question.
Wonderful. Yes, we did have a question. I am just going to take over myself as the presenter. So one second, where am I? Okay, welcome back, everyone. So thank you very much, Sayem. That was amazing. Before I ask the question, because we don't have a question, I would like everybody to have a look at this URL. So you can go to it on your phone with the QR code, or there is a URL that you can enter there. And that will allow you to put in feedback for Sayem's talks. This is really important for all of our speakers so that they can know. I'm sure Sayem's going to do this again, so this will really help him refine it. So please put in your feedback. Note, you will not get a credit on this one. It's going to say you might get one. I'm saving them for the third one, but please go in and put in your feedback. Meanwhile, Sayem, so we had a couple questions. I gave them the link to the GitHub repo you were using. And paste the link here. Sayem Or Peter, can you please put the ratings link into the questions box there? But a question from Andre Sayem was, any preference for Kafka versus Kinesis?
Yes, so I get this question very frequently with many of our customers. So the way I think of is it's about your strategy, how you want to, what the sources or what the streaming technology that you will use. Think about Kinesis. It comes up with native API. It has tight integration with AWS ecosystem, and it's a provision-based model. It's not a cluster-based model. So on the other hand, Kafka is open source, very well-known and popular product in the market, and it's a cluster-based deployment you do on Amazon MSK, and it comes up with open source framework. So I would say it depends on your choices as well. Instead of saying which one you can think of, maybe you already have an open source strategy, then definitely you can look for Apache Kafka. Maybe you already build something there. You have a good practice on Apache Kafka, so you keep building that. Or maybe you start with Kinesis data stream as well.
Such a typical solutions architect to say it depends, really, of course.
Yeah.
I think that's it for you, Sayem. So thanks very much. We've really enjoyed having you on with us tonight. And I will now welcome our next speaker. So our next speaker is Tom McMeekin. Tom is going to be talking about Amazon Athena federated queries. So Tom, I will let you take control.
Yeah, awesome. Thanks, Chris. Just bear with me, everybody, and I'll just start sharing my screen. Perfect. Well, welcome everybody. Thanks for everyone's time this evening at the end of the day. So what I'm going to be doing over the next 20 to 30 minutes is just giving you a bit of a peek into Amazon Athena and a new feature that's in public preview at the moment, available to customers to be able to start utilizing in their test environments and to become familiar with, is around federated queries. And hence why I have a bit of an asterisk there, just to call that out, as it's still in public preview, but certainly available to you to start to play with. For those who aren't too familiar with Amazon Athena, I thought it would be great just to start this session with just a bit of an overview of what Athena is, and certainly just to start to set that scene. So Athena was first launched in 2016, and so in 4 or 5 years, it's kind of a long way. But essentially, what it started out was really just providing customers a simple serverless platform to query their data that resides on S3, and so that enables customers to really start to query that data that's stored in their data lake. And so Athena was really there for particular use cases or particular personas within your business, around just to really get access to that data and query that across your data lake. Now, if you think about Amazon Athena itself, Amazon Athena is based on 2 well-known technology stacks. So that's Presto and Hive. And so for those familiar with those 2 technology stacks, Athena, if you have not used it, should be pretty familiar to you. Now, what we're also seeing for customers to use Amazon Athena, it's certainly started to evolve various different use cases around, as people experience how simple it is and easy it is to utilize, and how dynamic it is from a querying perspective. It's opening up different use cases. So we're seeing customers utilize Athena as that query engine to query operational logs, query application logs, for example. And also from a BI perspective, front end their common BI tool like Tableau, for example, using JDBC and ODBC connections into Athena to essentially enable end users easier access to particular data lakes and data residing in their data lakes. Additionally, from a self-service perspective, Athena is being used in the data scientists to essentially dip into various different stages or data marts across your data platform within your organization. And another interesting use case that we're seeing customers utilize is around the embedded analytics, and really just leveraging the breadth of the Athena API itself. So if you think about across those various different use cases, the first here that I mentioned was around that the ad hoc query use case, where essentially we're taking data that's residing in various different data sources. So here in this diagram here, we've got Amazon Redshift, S3, Amazon RDS, so it could be a MySQL or Postgres database, and then also various different other databases that may be residing on customers' EC2 environments or even on premises, and ingesting that into your data lake. And then leveraging the Glue Data Catalog as that centralized metadata repository to enable tools like Amazon Athena to query that data that maybe have been ingested into that data lake. If you think about that SaaS use case that I mentioned in the previous two slides, this is one that's becoming really interesting, I think, in enabling customers to leverage Athena to query their longer tail data sets that might not necessarily need to be readily available in their hot data stores. So essentially enabling them to lifecycle data out of their NoSQL data layer or even their relational data layer, but enabling their end users, and in particular this being a SaaS use case, their end applications to be able to query that data still through the Athena API. And we're also seeing Athena being used in ETL use case. And so Athena supports create table as and insert into statements. And so essentially enabling customers to write SQL-based ETL and use the Athena platform to perform those ETL jobs. And so enabling you to persist that data in Parquet as a transformation task in that first stage from raw to your staging data zone. And then enabling, again, Athena or any other querying tools from a presentation layer perspective to be able to query that data, depending on that use case and the personas who are looking to query that data set. And then lastly, from a data science perspective, being able to connect your Jupyter notebooks, for example, data scientists can utilize those tools that they're familiar with as querying data sets that might be in their transform zone or their staging or curated zone, or even in the raw data set stages as well. So that's a bit of a short, quick, brief summary of Amazon Athena, just introducing you to the service, or maybe even some use cases that you might not have been familiar with from using Athena for. But really, what we're here to talk about this evening is federated query. So federated querying was launched as a public preview service around reInvent timeframe last year. And so it's readily available for customers to use today, as I mentioned. But what is it? So think of Athena as I mentioned, was originally that service to directly query data sets that have been ingested into your data lake and residing on S3. But what we heard from customers and saw within that market is definitely demand in wanting to aggregate data that might be residing or continuing to reside on other data stores. And so hence federated query was born. And so essentially, in a summary, federated queries enables you to bring or to connect the Amazon Athena query engine to various data sources. And those data sources might be across on-premises or AWS services or customer hosted services on EC2, but essentially connect the Amazon Athena query engine to perform ad hoc queries to those corresponding data sources. And if you start to really think about a data landscape, it might be a data landscape familiar to you looking at this diagram here within your organization, it's pretty typical. If you think about it from an application perspective, developers are really focused about picking that right database, the purpose tool to store their data, depending on that microservice or the application that's being developed for that specific use case. And certainly, if you think about it from a transactional perspective or from an operational perspective, those requirements are definitely going to differ from a querying perspective. And so, so hence, if you think about that challenge there, and then also the challenges that surround having to bring that data towards closer to the querying engine. So building up your pipelines, maintaining those pipelines, and effectively curating that data. There's effort there that data engineers and teams need to be mindful of. And so hence federated querying is really focused at trying to, I guess, bring a different approach to that problem statement, and essentially bring the query engine to those data stores without necessarily having to move that data. So let's double click a little bit around what does a federated query actually look like. And so a federated query is really made up of what's called a source connector, and that source connector is a simple Lambda function. So it's a Java application, and essentially that connector is that bridge between the query engine of Amazon Athena and that federated source data. And so as you execute a query within Amazon Athena, Athena is running essentially an extension of that query engine in Amazon Athena. And so when we run that query, Athena fans out those Lambda functions in parallel to read that data source and that metadata in that data source. Now, the number of these fan out invocations will depend on the concurrency limits within your account. So that's something to be mindful of as you start to play around with this, and certainly when you start to interact with downstream data sources, there's mechanisms on how you can control that behavior and that back off behavior. So if you do run into constraints on that downstream data source, there are mechanisms, controls to enable you to do that. So I'd recommend you diving deep into the documentation as you start to experiment with federated queries. Now, what you can also do is you can simply query a single data source, but the real power is running a simple query across multiple different catalogs or multiple different data sources. And so that coming back to that diagram here, essentially a single query to be able to query your product catalog and also bring together your advertising data in one query. Or even your payment information alongside order processing or your customer details within your CRM. So really being able to aggregate those various different data sources together. Now, I mentioned Amazon Athena manages the parallelism, but Amazon Athena also pushes down predicates to the downstream data source. So again, improving performance. So federated query is really simple to use. So I like to keep things quite simple, and 3 simple steps of number 1, we have to deploy that connector. Now AWS provides a good handful of common data sources connectors for those, or you can write your own. And I'll show you the SDK towards the end of this session around how you can start to explore and doing that yourself. But most of the common data sources are there for you to effectively quickly deploy, and that's deploy as part of the serverless application repository. There's an application in there that you can deploy. That's the Lambda function with all the configuration information. You register that data source within Athena, you give it a catalog name, and then you run your query. So really simple, and really simple to get started. And then once you've deployed that connector, you can start to query the data sources. So I hope that gives you a bit of a good intro and a baseline understanding of federated queries. Why don't we go over now to the console and just take a little bit of a deeper dive look of running a couple of federated queries. So first and foremost,
zoom if you can, Tom. Make the text a bit bigger.
Yeah, just 2 seconds. How's that, everybody?
Much better, thanks.
Cool, awesome. So the first thing to point out is to activate the feature, you have to create and reconfigure the console or the work group that you're going to run the queries into this Amazon Athena preview functionality work group. So there's documentation there within our docos that to step you through it, but that's the first number one step that you need to do before you actually start to play around with these new features. And it's not just federated queries. There's user-defined functions. There's ML inference through SageMaker, endpoints, etc., like that. That this will open this up to you to be able to also start to test. And so what I've got here is I've got a number of different data sources that we want to query. So I've got a HBase cluster that's running or that's hosting some line items for our data source. We've got a number of different supplier and sales information that's sitting in a relational data store of MySQL and hosted in RDS. We have a whole lot of part information. So sitting in our DynamoDB environment, we have 2 tables there, and also we have a Redis cluster that's managing a couple of different tables here. What I might do is I might just flick back to the slides and just quickly show you a bit of an architecture. I apologize, I should have shown you this first before flicking to the console. So you can see here, this is a quick overview of the various different data sources that we have and those tables that we're going to start to query within this. So this is all based on the TPCH dataset, so the open standard dataset. So if you're familiar with that schema, you know, some of these queries should be pretty familiar to you all. So let's just flick back to the console. So let's go run a query, right? So we've got these configured. So let's run this MySQL one first of all. And so what this is going to be doing is, again, you know, executing a Lambda function that I have deployed and querying via that endpoint via JDBC to that database and that table, and then we've returned those results there. So really quite simple. So I've got a bunch of these connectors already configured. So you can see here over on the left-hand side our data sources. So the 3 I've got configured at the moment is I've got a HBase cluster or data source connected. We have our MySQL database configured here, and as I expand here, you can see those tables as part of that database. And then I've also got my Redis cluster as well configured. What I don't have yet is our Dynamo connector. So, and that's what I want to do with us today, just to step you through that process of using the AWS provider connectors to connect the data source. So if we click on Connect Data Source, there's a couple ways to do this, but this is probably the easiest approach to follow the bouncing ball. And we select Query a Data Source. But one thing I just quickly wanted to call out as well is a new feature that we announced somewhat recently, is the support for the native Apache Hive metastore. So if you're wanting to use Athena and you have your catalog based on your own self-managed Apache Hive metastore, so Athena has recently announced support for that. So you can start to integrate Athena into other catalogs alongside the AWS Glue data catalog. But back to what we're doing. So we're going to select the beta feature here of the query a data source. And this is where you can start to see the available connectors that we have for you to use today that AWS has provided. Now, again, this is in preview, so expect this list to continue to grow, not just for AWS native services, but certainly think of it from a marketplace perspective. You know, a lot of partners, technology partners that AWS partners with, is certainly thinking about how they can utilize these connectors to query or to enable SQL queries into their own platforms themselves. But we're going to deploy a DynamoDB connector. And here we start to get a little bit more deeper in deploying that Lambda function. So at the moment, I don't have a DynamoDB Lambda function deployed. So we can just configure a new Lambda function. And what this is going to do is this is going to make a call to the serverless application repository. So it's a great repository for all serverless applications that people can publish, both AWS and anybody who's willing to publish an application. And so this is where the connectors live. And so there's a SAM template that's backing this. So you can have a look and deep dive into that template if you wish. But for sake of time today, we'll just go ahead and configure this. So the first thing that we need to do is we need to define a spill bucket. So a spill bucket is where the data is returned by Lambda if that function execution, that specific Lambda invocation, exceeds the Lambda limits. So things like the execution time, memory, etc., like that. It will persist that data in that spill bucket. So while that query is continuing to execute and other parallel invocations are occurring. So I've got a bucket here that I'm going to just copy from my notes and copy that in. The next thing we want to do is we want to define a catalog name. So I'm just going to put Dynamo. And then the last thing I want to do, just to make sure that there's no overlap with spillage from other connectors, is just to change that prefix there, and then we'll hit deploy. And so this is going to deploy our SAM template, which is our Lambda function, our Java application, and that will take a couple of seconds to deploy with CloudFormation. Hopefully not too long. And we'll see here, it will start to load the resources. So it's created the IAM role and then the Lambda function itself. So if we go back now over to the Athena console, we do a refresh, we should now see the Dynamo function. And we'll just give it the same catalog name that we mentioned in that deployment. We hit connect. And then we see Dynamo there. So if we go back to the query editor, we should now, if we go back to this simple one here, we should now be able to just run a quick query against Dynamo. So quick scan the table, and we'll also see it listed under the data sources as well, and the two tables that we have. So really easy to get started. It's almost as simple as 1, 2, 3, as the slide says. Maybe there's a 2.5 or a couple of half steps in there, but pretty easy to get started, particularly for those data sources that we provide you access to as part of the preview. Now let's have a little bit of fun and start to see if we can break it a little bit and run this multi data source query where we're making some joins between our RDS MySQL database, our HBase cluster, a Dynamo table. That's it. So 3 data sources here. And again, what will be happening under the covers is each of those Lambda functions are being called upon relevant to the data source. There'll be parallelism being occurred or executed as part of each of those invocations, and then making downstream calls to those relevant data sources. And so this won't take too long to complete. We should get something back shortly. There you have it. And so really, we're bringing the query engine to those data sources. We're not having to extract that data, transform it, and store it in a centralized storage location for this querying to occur. So really starting to flip that model of what you could potentially do and utilize Athena for as part of your analytics capabilities. So let's just go back to the slides and let me rehash a few things that we've just touched on in a little bit more detail. So first and foremost, this is probably, I think, the easiest but the most critical takeaway for everybody to be familiar with is just creating that work group and making sure you join that work group or switch to that work group in the query editor or the query tool of choice, whether you're using your own IDE, and configuring that in the JDBC connection or the driver. For those people who are taking specific note in some of the queries that I ran, And if I flick back to the console, what I was actually doing is I wasn't actually utilizing the actual data source itself. What I was doing is I was utilizing the registrationless federated query as part of these queries. And there's no reason for me doing that. It was just more out of it's something I had pre-canned. But what I could do is effectively, take that out, and then that's referring straight into that data source and that catalog that we're running there. But that enables you to effectively to do some prototyping if you're looking to run those prototypes, or not necessarily publish or make available the connector to the catalog while you're building up that connector. It certainly just sort of creates that sort of, I guess, that flexibility from a decoupling perspective for you. So something to take note about there. And then a whole bunch of connectors, as I mentioned. So we have HBase, DocumentDB, Dynamo, JDBC into various different data sources, MySQL, Postgres, Redshift, Aurora, etc. Redis, and then some interesting ones. So CloudWatch Logs. So a readily available connector for you to start to run SQL queries into your log groups and log streams that are being stored, or your logs being stored into your log streams, and then also from a metrics perspective as well. And then there's also a TPEDS data generator as well to help you build up some familiarity if you are going to build up your own connector, and as a reference point there for you as well. So building your own connector. I think this is where it's certainly going to grow, and those connectors are going to grow quite rapidly when the feature I guess continues to be developed and is released as a generally available capability. But there's I guess multiple different areas that you need to be mindful of, and so this GitHub lib here is really the starting point of starting to understand a little bit more what's happening within the Java application for the federated connector. So things like S3 spill, which we manage, which I touched on earlier, as we deploy that Dynamo function. So effectively, that function or that storage location to store data, if the Lambda function encroaches any limits within the execution or specific invocation. Partition pruning, enabling you to only read relevant partitions within the downstream data source. Parallel scans, as I mentioned, enabling you to manage those, and with congestion control as well. The other thing to point out is the request and response structures are all built on Apache Arrow. So an open data standard here, or a language that Amazon's contributing and it's available for customers to utilize. So your connectors and querying that language that you're building here, there's an agnostic capability as part of the adoption and usage of Arrow. And then from an authorization perspective, so when you're using AWS provided connectors, it's all inherently using the native integration of IAM, etc., like that. But certainly that's something you need to be mindful of as you, or if you do choose or need to build up your own data source connector. And that's typically going to be for proprietary systems that you might have within your environment. So self-service ETL. So I mentioned ETL and Athena being used for ETL at the start of the session as one of the use cases. And if you think about the power of federated query, again, that ETL use case continues to grow. And so, being able to run a SQL query that reads multiple different data sources, running a CTAS or an into statement to extract that data or query your downstream data sources, store that data within S3, and a native Athena catalog a native Athena table within the Glue data catalog in Parquet format, and then enabling you to query that, and then also being able to schedule that using Lambda queries, etc., like that. So really interesting use case, I think. So that's Amazon federated queries. Now, what I've also done is I've just snuck in a couple of other features as well. That essentially is being built and being effectively made available because of the capabilities that Federated Query has enabled within Amazon Athena. And the first one is user-defined functions. And so alongside being able to create your own connectors and use the provided connectors, you can also create your own UDFs and call upon those as you run your queries. And so, yeah, from a use case perspective, it's really quite a powerful capability here, where you can start to perform some redaction of data. You can compress and decompress your data as you're running your queries through Amazon Athena. So yeah, really really quite exciting from an expandability perspective. And so when we look at what actually is UDF from an Athena perspective, so it's essentially so I've taken an extract from a UDF here. It's a Scala function. So we provide you as a boilerplate code, a Java application or Scala application, and you can then write your own specific functions that will be queried on a per row basis through your query. And so essentially, if you look at this example here, where we've got our Athena query down the bottom and our Scala function at the top, and so within our query, we're specifying to use what's this function, the redact function. We're going to pass in a particular column or particular value. We're going to execute against this Lambda function. So similar to our federated query connectors, we have a Lambda function that will be executed in parallel on a per row basis for this query. And then we're passing in that value here, that CNAME, so customer name. And so this is effectively performing a simple redaction. And so I had to cut the string length or the string here, but essentially it's a simple string builder function to perform some redaction. And so I do have that, and we do have time. I do have that as a demo as well, just a quick example of that. So here we have that same query.
You've got like 2 minutes.
2 minutes, cool. And so essentially this will give us a bit of a feedback on that redaction of strings. And you can see here the redacted name versus the non-redacted name. So really simple. More information in the SDK for you to dive deeper around how you go about building those UDFs. And the last example that I'll step through, now I'll stay, given that we've got time restrictions, I'll stay in the console, is using Athena to run ML inference against a SageMaker endpoint. And so if you think about this capability here, so effectively this use case is enabling you to run queries within Athena to score your data against an ML model that you've built, all through the single query. And so what I'll quickly do is, just one thing I need to do is I need to grab a pre-deployed SageMaker model or endpoint. And so SageMaker, for those who haven't used it, is a great platform to start to build, train, and also deploy your models. And so SageMaker will deploy your models and give you a REST API as that endpoint. And so let me just grab that endpoint configuration here. And so this is what I need to pass into that query. So I've just done a simple RCF model that's going to score our data as we run this query. And it's going to perform some anomaly detection. So as that runs, we can quickly look at this function or this query here. So we have our SageMaker endpoint, which is that endpoint. We're passing into this detect anomaly function as part of that endpoint or that model that we've built. And then also we're running that from a connector and connecting that into our MySQL RDS instance as well. And there you have it. Here, this is our scoring for that RCF model that we had deployed. And that, I think is me. So lots of information to take in, and you know there's lots more information to go that you can go through within documentation, and so I'd highly encourage you to jump on our online docs and start to review the preview documentation and the preview capabilities. And within this documentation that's listed here, links you to that GitHub repo as well that I had up on the previous slides. And so again, there's lots of boilerplate code that you can utilize and you know, start to deploy, play, and dive deep and get familiar with the service feature. That's pretty exciting. And the last link to you know, a great go-to one to always have bookmarked if you don't have it is the top 10 performance tuning tips for Amazon Athena. And so really relevant for you know, just running Athena and trying to ensure that you're getting the best performance queries, but also reducing cost and making it super cost effective. And that's it from my side, Chris.
Wonderful. I'm gonna take control. You actually had lots of questions.
Awesome.
Show my screen. Come on. Why isn't it letting me? Not showing anything. Go to webinar. What are you doing? Hang on. There we go.
Yeah, I'm gonna put them up as well.
Can you change the presenter to me? For some reason, it's not wanting to let me.
Oh, yeah.
We're working so well up to this. I might just go ahead and get wow, it's just going bonk, bonk, bonk.
I can't. Change presenter.
Chris, you want me to do it? I think I have access still. I can switch it to Melody.
I think so. I think we'll go ahead and just switch straight to Melody because it's being a bit funny. Tom, you had quite a lot of questions in the questions box, so maybe during this last talk, you can answer some of those directly in there. The biggest one is around people want your slides.
Yeah, perfect. So certainly we can make some of that available for customers, absolutely.
Okay, no worries. I will hand over to Melody then.
Thank you. Thanks all.
Thank you, Tom. Thank you, Chris. Okay. Can everyone see my screen? I'm not quite sure which screen I'm sharing right now. Hello?
Yes, we can see your screen.
Okay. All right, cool. Let's get started. Hi, everyone. Thank you for staying with us till the last topic of the meetup tonight, and hopefully you had a great time and learned a lot so far. My name is Melody Young. I am a data specialist SA at AWS. So tonight I'm going to share with you a self-service ETL reference architecture I designed recently and demonstrate to you how it works. So you may be wondering what self-serve ETL means to you and why should we care? And as a data engineer, does that mean I'm going to change my role? Let's park those questions. I will answer them shortly. And then we are going to count down to a very exciting demo, or maybe two demo if we have time, by talking through the pattern with 4 success enablers and 3 technical components, 2 types of personas, and 1 abstract ETL framework. Okay, so let's start with what self-service ETL is about. In short, it means give decision makers more controls over their analytics work, encourage our non-technical users to drive the right business outcome with a better understanding of their own needs. All right, so you might think that sounds fantastic to the business, but as an IT person, what's the role for me when I'm not writing data pipelines? So in this case, your focus will be shift or changed from creating ETL to making ETL build accessible to our end user. Let's get head around it. I like to think of it in terms of Lego blocks. So engineers design new Lego blocks that non-IT users assemble in creative ways to create new business opportunities. Okay, so we have 3 technical components in this reference architecture. The first one is AWS Service Catalog, which is a fully managed service allowing our organizations to create and manage a set of IT services that are approved for our users to use on AWS. The second technical component is Amazon ECS. It is a managed container orchestration service. We call it Elastic Container Service. So we have a lot of customers such as Duolingo, Samsung, GE use our ECS service to run their most sensitive and mission critical applications because of it is a security, it is secure and reliable and scalable. So the last component is ARC framework. It is the foundation of the ETL jobs in this pattern. Which is an open source data processing tool built on top of a Spark ecosystem. Integrating with AWS offerings, it is available on public Docker Hub and also Maven repository to help our organizations to address various data problems. So now let's take a deep look at the service catalog component. So we have 2 personas interacting with the self-serve platform. And so they are service catalog administrator and the business end user. As a business user, you consume the service and build ETL in a self-service manner. And so in this scenario, the end user actually refers to data or business analyst, data scientist, or any business users who are comfortable to manipulate their data in SQL. So it's not necessarily developers or SQL developers. From the IT perspective, you as a service catalog administrator will be responsible to create a CloudFormation template, products, portfolios, users, tags, and assign constraints to secure and standardize the usage. Additionally, to provide an abstract layer on top of your ETL layers. So that then you can serve as a product to your end users, right? So as an example today, I will just use this open source enterprise ready ETL framework to prove that the data pipelines can be easy for our non-IT users to manage in a self-sufficient way. So we have a unique ETL framework called ARC framework. Here is a 1-slide summary to explain what is ARC framework is about. And so it is not ETL job or Spark applications that you are familiar with, right? It is actually a Scala code-based abstract layer sitting between the Spark ecosystem and ETL jobs. So from the user perspective, right, ARC has done all the heavy lifting on your behalf. You don't need to understand the underlying Spark technology and how to allocate your compute resources, etc. Instead, you will be just focus on editing your job flow definition file without writing any custom code. So for example, you can tell the framework where is your source input, what type of output you want to convert to, and what kind of a business logic to implement in SQL format. So basically your entire ETL pipeline will be just a single configuration file. So to prove the self-service ETL is achievable, I'm going to follow the 3 steps in this reference architecture to demonstrate tonight. So the scenario on this point is that I am a pricing data analytics analyst who needs to build a utility pricing model, for example, tailored for each state. So I'm looking for a SQL-based solution to solve a SCD type 2 data problem against some customer contact data. So here is how I tackled this complex problem in a self-sufficient way. Okay, so before we get started, let's just refresh our memory about what is SCD data problem first. Okay, so let's start with type 1 and type 3, which are just a table update on existing records. If you take a look at the example in SCD type 1, you can see we just simply replace that state by WA, right? And if you take a look at the example in type 3, we can see the current state is Victoria with effective date of last year date. Then once we change it, we move on the Victoria to the previous state as additional column. The effective date is changed to this month. So tonight's focus actually is type 2 SCD problem, which is actually different from type 1 and type 2. It tracks historical data by creating multiple rows for a given natural key in the dimensional tables. So we normally use merge operation to achieve this. Right? If you have a data warehouse or database background, you probably are very familiar with the merge statement in the SQL. So what gotta happen is currently we have this existing row, right? And when we have some existing data coming with changed state, what gotta happen is so we expire the existing row first. By putting today's date or current date to validate 2 with the expiry date, and the active to indicate this row is not active anymore, right? Then simply append the updated record set into this table. So this is SCD2. In my demo, I'm going to just initially load 1,000 rows with some customer contact data information. Then I will simulate a second load for the incremental data processing, which contains 1,100 rows with 92 overlapping rows. So at the end, we are expecting 1,192 rows in total after they merged. Okay, let's start it. So I'm going to switch over to my console. So this demo actually is in my GitHub repository. I can share with you at the end of the session today. So I actually forked from our public repository, AWS sample, and just reused some blueprint from the Service Catalog reference architecture. As you can see, we are using the ECS component, right? So we are just focused on that ECS, and I created the customized branch. And so in this branch, actually, it contains my customization. And so I will follow those 3 steps. Firstly, we're going to launch a ETL cluster. Actually, behind the scene, it will spin up a couple of basic infrastructure resources on AWS, and especially it will create one ECS cluster. So ECS cluster is just a logical group to put all your container services or container tasks together. So in this scenario, we can just think of as a single project for the pricing model build. Okay. And the next step is we are going to launch a Jupyter Notebook as a service inside this ECS cluster. So the ECS service basically is a long-running container inside the cluster. So which means it provides a high availability. If you accidentally delete one Jupyter Notebook instance, it will come back online on its own. So it reduces lots of your implementation effort and maintenance overhead. It's all built in, right? The third step is we're going to launch a ARC job trigger to orchestrate that Jupyter Notebook we already fully tested and ready for productionized. Right. So as the output of this demo, we should be able to see some entries created in the Glue data catalog with a table schema information, and also we can query against Athena on top of the S3 bucket files straight away. All right, so we can start from just launch the CloudFormation template from here. So everyone can give it a try. It doesn't require you to download the source code. You just click this button. It will take you to your AWS account. So you just click next.
Melody, can you maximize that window and maybe zoom in a bit?
Yeah. Is it better, or should I zoom out?
Much better, thank you.
Okay. Cool. So we just click next with all the default settings. So we don't need to change anything, and just make sure you tick those, then create stack. So I already have an existing stack created, so I'm just gonna cancel. So once that stack created, within 1 minute, you will see all of these nested portfolios CloudFormation template will be created in your account. All right. So at the same time, it will create one business user and end user assumed role for you. Once that is done, I should have just keep my GitHub online. So once that is done, you can log in acting as that end user. So this is the end user has been created in your account. So you can log in. So how to switch to the different user? So we click switch role, then put your account ID in, then role there. Where is my account ID? All right. So we switch role. So right now I'm acting as the pricing analyst. Right, to self-provision all the necessary resources and also create the ETL pipeline for myself. As this pattern is highly secured and with lots of constraint of permission access, so you can see I don't have any authorization to perform any CloudFormation operation. So the only permission I have as end user is to see all the products available to me, all right? So let's just follow those 3 steps. The first one is to create a ETL cluster. So we just simply launch the product. So behind the scene, it is a CloudFormation template for me, right? So we can just say, I don't know, pricing cont type cluster. Let me just zoom. Yeah, it's full screen. Okay, so just a pricing cluster, then click next. And you can put a text there, say, for example, department. My department is marketing, for example, and I do next. And you can try to click create a new topic, SNS topic notification to your dev DataOps engineers. Let's see what's gonna happen. So we're gonna create a new one, say test. So actually you are not allowed to create a new topic. So that's how restricted your role is, right? So let's just untick that. So as end user, we only allowed to create this cluster. So I just launch this ETL cluster. All right. So since I already have the ETL cluster created, yeah, so I'm gonna just reuse it. It is kind of once-off infrastructure provision. So it will give you some VPC and some networking components and plus some load balancer behind the scene. So the next step is we're gonna launch a Jupyter notebook service for myself to develop the ETL pipeline in the self-service environment, right? So this service enables me to create Jupyter notebook instances as many as I want. So this is my current permission I have. So pricing Jupyter. As you can see, previously when I acting as a service catalog administrator, I created multiple versions to provision the Jupyter notebook. So actually the current one, it is connecting to a particular Docker container image with a specific version. So in this scenario, let's imagine you are using the Jupyter notebook that is productionized or enterprise ready. However, in the backend, our data engineering or data engineers or developers, they are trying to improve this Jupyter notebook. Say, for example, putting more constraint on it or enable the single sign-on components. So they are working on a version of Jupyter notebook. You don't want to be interrupted by them, right? So we can easily control the version and by specify specific version numbers. All right, so this is the version number I'm using at the moment, you see. So I can specify, of course, I'm an end user, I have no idea what is this, right? So this is all provided by the default template value. And as you can see here, there's a container size. So this is basically allowing me to decide what's the size of my workload. Do I need a really large cluster or large container resources to compute? Or currently I just need to process 1,000 rows, so I don't really need a big cluster. So there's some indicator here in terms of the size of the compute you can choose. Then we can click next. One more thing I would like to call out is the Data Lake S3 bucket. So this S3 bucket has to be one of your existing S3 bucket in your AWS account, right? So currently this is my default one in the existing account. So if you don't change that or forgot changing that, it means your blueprint will be trying to access to my S3 bucket. And as a result, it will be failed because you don't have permission to access to my S3 bucket. Okay, cool. So let's just launch this Jupyter notebook instance. Because I was just saying the name is pricing Jupyter, but maybe we have a lot of other pricing analysts using the same service. So this number automatically assigned to me to maintain the uniqueness. Okay. So after a few seconds, you can see there's a CloudFormation template URL come back. Actually, you are allowed to see this particular CloudFormation template provisioned by yourself. So you can watch or monitoring the progress of your infrastructure provisioning. Right. Okay, so when we are waiting for this Jupyter notebook instances coming online, we can use the existing one that I provisioned previously. So we have one Jupyter notebook called HR. So that's from a different department. We can reuse this one just for the demo purpose. So once the Jupyter notebook instance is provided, you should be able to see there's a notebook URL link here. So just open it. So in that Git repo I showed you earlier, there are two example notebooks you can upload. So for example, you can just upload the SCD type 2 workshop, Python, that one, yeah. Override, that's fine. Okay, so let's have a look at the SCD type 2 problem. How can we tackle this in this notebook, interactive notebook environment? So firstly, I just say I don't want to display lots of rows just for testing purpose or easier to demonstrate. So I just show you top 12 rows. So first of all, I know my source data, that 1000 row, come from a CSV file storing in my ARC demo 2020 folder. And so this parameter, environment parameter, actually automatically take from that CloudFormation template from a service catalog. And the name was Data Lake S3 bucket. So that will be your existing S3 bucket. All right. So you don't need to change that by hard code your S3 bucket name. It's already passing. All right. So we can just directly execute that. And so it gives me 12 sample rows from this initial load CSV file. As you can see, it's very easy to modify those attributes because it's plain English. For example, I know my CSV file source data doesn't have any header, so I just put false there, and it was delimited by comma, doesn't have any quote, and I'm going to give this output a table name as initial raw. Sorry. So if you are not sure how to construct this JSON format to describe the stage, and we have a link in my Git repo. So this is the ARC ETL framework online documentation. It has all the it follows the principle of ETL, right? So when we ingest, we know it's extract, and it is delimited file type. So we straight away go to delimited extract. It has a fully detailed level of documentation you can follow, and that's all the attributes you can use. And there are some compulsory field indicator there as well. So say I have no idea what this ARC ETL framework is, so I just copy this block, right, and paste into my Jupyter notebook, where it is here, right? So for example, I just copy here, and then I replace some of those attributes to my correct ones. So that's how I construct my ETL pipelines with a self-sufficient way. All right, so since initial data is read into the Jupyter notebook now, we can have a look at the schema. It doesn't have any columns, right? Because this CSV doesn't have any header. So the next step is we are going to apply the data type to this table by providing this metadata JSON file. That is just think of as the schema registry file or metadata information file. So you can infer your tables with the column definitions here. Immediately we can see the columns. And let's check the data type. Here we go. So the data type has been converted as well behind the scene by the ARC framework. So I don't need to do the mapping and change the ID from string to integer, not at all, right? Additionally, the ARC framework created 3 extra internal columns. So this column, especially _errors, give me an indicator for me to control my data quality during the data type transformation process. So if the above data transformation process failed or the stage was failed, I can write a simple SQL script here to fail fast my job. So to stop, continue, because the type transformation was failed. I can decide that. Or alternatively, I can provide a certain threshold, say maybe the failure ratio is 10%. I can get it passed and get my data pipeline continue to run. All right. So here is basically checking this column _errors. if there's any exception error messages contained in this column, and then we reckon it has an error for that particular row. So you can see every single row should have some exception messages there if there's error happen for that particular row conversion. So it's quite granular level data quality control. And the next step is we are going to add some calculated field or columns for the SCD type 2. Right. Remember, we have a couple of fields such as the validate from, validate to, is it active currently? And also the last column is the checksum by concatenate all of my columns that I'm care about, so that I don't have to check every single columns matching each columns. I just combine into one hash code so that I can just keep checking the existing record set, or it's a brand new record set by this column. All right, so this valid from column was created by this particular environment variable. So every time when you execute this stage, it will generate the latest timestamp. We will reuse this environment variable to populate the valid to columns later on. So now, since we got all the record set ready, we are ready to output. So the output, which is load stage, is using the Delta Lake open source APIs. So basically, Delta Lake is created by Databricks, and they open source this part of the APIs. So we utilize that to optimize our data lake to support ACID transactions and the time travel query operations. So now we already finished writing back to the output S3 bucket. Now, let's try to implement the incremental load. So ideally, it should be a second ETL pipeline. Just for the demo purpose, I'm going to put it into the same pipeline. So now
we've got about 5 minutes, Melody, tops.
Okay, thank you, Chris. Almost finished. So we gotta ingest the incremental CSV file, which is called update contexts. Follow the same rule, reuse all the metadata information files. So pretty much exactly the same. You just need to define the temp column, temp table name with the correct ones. Then we control the data quality, make sure the above stage was successful. So you can see there was 1,100 incremental rows were trying to load. And finally, we add 4 extra columns to construct the SCD2 type of tables. This is the critical step. So we gotta prepare the data set for the SCD type 2 insert. Basically, we gotta duplicate the ID column, right? Call it merge key. So for existing column, for existing record sets, we gotta put null as the merge key, which means the null key means actually all these existing record set will be appended into the existing tables. We are not going to update the existing rows, right? Then we union all with the existing rows. Finally, this is where we implement the merge operation. So I will take you through with this one. This is the output for the final SCD2 output. And as you can see here, the condition, the join key is by merge key, not ID. So remember, we have 92 existing records. They have a null value in the merge key. That's how you can get them appended into the existing tables. So for the checksum, that means if any columns has been changed and the current record is active, then we update, right? This is doing the expiry, the current existing rows. So we just set is not current anymore, and the valid to column will be populated with the current timestamp. finally insert everything if not matched by the merge key. That's it. So let's just check, is it working? So this is time travel operation, basically. When we query by the relative version, 0 means current. If we do -1, that's a previous version. So we already executed current. So let's see, do we have a 92 columns, rows are expired for the current merge? Come on. There's another thing. Okay, so 92 rows were expired. Let's take a look at one example rows that has updated by this incremental load. So with ID number 12, this user or this business user already have contact changed. Let's see what gonna happen after we merge the records. So you can see initially this Dr. Elvia was living in WA. Then after incremental load, we changed the state to HI. You can see this record is expired. So that's pretty much it. The last stage is just a link, set up the mapping from our Delta Lake tables to Athena so that we can query inside Athena similar to these queries. Okay, that's all from me. That brings us to the end of the demo. Let me just recap what we have talked about. How many minutes do I have, Chris? 1 or 0?
Two left.
Yay! All right, cool. Okay, so I'd like to quote someone's blog post to summarize the key takeaway tonight, right? So someone they wrote this blog post saying basically data engineers shouldn't write any ETLs because the reason behind it is because we should focus on what we do best, right? For example, build this awesome self-service platform by leverage AWS Service Catalog, build all the CloudFormation template, make it automated in front of your end user. So by abstracting, generalizing, and create efficient, scalable solutions where we are needed, right? Instead of creating some ETL pipelines to produce some data that we ourselves never get to use. Okay, so that's it from me tonight. If you are interested in the demonstration tonight and want to play with it, here is some useful links for you. The self-paced lab is on the bottom here. Basically, it's pointing to my GitHub repository. Cool. So thank you all for being here with us and taking the time watching our presentations. Have a good night, everyone. Let me just hand over to Chris to wrap up. Thank you.
Thank you, Melody. Has everybody got a screenshot of that before I again attempt to grab control of the presentation? So quickly screenshot that. Also, if you're okay with uploading the slides, Melanie, we can upload them and share the link. All right,
sure,
I'm
no
taking
worries.
over. This time, I figured out what went wrong last time. If anybody knows the trick to run a webinar without a serious error, please let me know. So thank you so much, Melody. That was amazing. This is the link to rate Melody's talk. Now, please, everyone, this is the one where you will get your credit code as long as they haven't run out, but I think we've got plenty for the people who are still here. So please go to ratings.go-aws.com, same URL that we used earlier tonight. It's code 146, or you can use the QR code here. It will only be good for 10 minutes, okay? So just go do it right now and give Melody her feedback on her talk. And you can do that while Peter comes in. Come on in, Peter. Come on in and wrap it up for us. And I will do the slides for you.
Awesome. Thanks, Chris. You can hear me all right?
Yeah, we gotcha.
Cool.
All right.
All right, next slide. Yes, okay, so just a quick reminder that, yeah, our data is on, I believe, next week. So you can get your tickets still. give that a go. Some really great people there: Claire Carroll, Greg Root, Dennis Bauer. Awesome presentations. So really excited about that conference. So go check it out. It's going to be great.
Dr. Dennis, I love her. When I've seen her talk, she's amazing.
She's also talking at AWS Serverless Community Day, if serverless is your jam. So that's happening this Friday.
Oh, we should have had a slide on that.
Yeah, we should have.
Would have been smart.
Yeah. But yeah, so DataEngBytes. This is going to be an awesome conference. Excuse the confusion on the URL and the name. We originally started off as DataEngConf AU, and then we sort of changed the name to DataEngBytes to sort of come up with some bite-sized data engineering, sort of 25-minute sessions, because everyone's got Zoom fatigue right now. But it's going to be a bunch of fun over 2 days, 4-hour sessions each. We've got a great team, Francisco Lewa, who helps out running Brisbane Data Engineering Meetup. Leo Hoare, he does all of our sort of web design. Awesome data engineer, but clearly multi-talented. Katie Pearson. Oh, you've got that on your screen.
Sorry.
Oh,
Yep. Thank you.
I'm
just seeing some comments that maybe the rating sphere form isn't working.
Okay.
I'm seeing a few people say that. Let me just quickly, while you're talking, I will set up a new one that will definitely work, because maybe the timing, since our timing ran over, I'll quickly set up a new one.
All good. Yeah, so just a few more of the team: Katie Peterson, Karen Davis, Simon Aubrey, and of course me. So, you know, like great team. Also, we've got an awesome committee, a bunch of data engineers that just wanted to create a cool conference. So looking forward to seeing you all there. Feel free to grab a ticket, and if you're interested, also submit a paper to the CFP. It's closing in about a week's time, so do get in fast. I think that's
I've just put the new QR code up, so everyone, can you please test that for me right now and let me know that that works, because that should work. I'm watching the questions. I could actually test this myself as well. QR code, open. Melody's talk. Yep, should be working. You guys should be able to see that. Okay.
Perfect. Just the last slide. So, yeah, so all of these conferences we're able to put on. Oh, the one before. Sorry about that.
That one.
Yes. So these conferences, we've got free tickets, and it's all due to our awesome sponsors. AWS are on board, so real big shout out to all of them. Thank you so much. Otherwise, we'd have to charge you all an absolute bomb to come along, but it's free, so that makes it all the worth its while. Next slide. Finally, just to end out. We're usually on Zoom webinar. You can catch us at the Data Engineers Meetup Slack group. We've also got a Twitch channel, DataEngAU, with the YouTube soon to come. So anyway, thank you so much again, AWS. I find these talks incredibly useful. Really helps me in my day job. So thanks again, Chris and team, for putting it all together, because I know it takes a lot of time out of your day. But certainly I really do appreciate it. So thank you.
And thank you, and thanks to all the folks. Thanks for letting me know that wasn't working. It's fixed now, and I can see lots of people are managing to do that. So that'll stay up for 10 minutes. So even after the call ends, you can still put in your feedback and get your credit code. And thanks, Peter, and thanks to all our speakers. Thanks to Sayem, thanks to Tom, thanks to Melody, and thanks to Syed as well for running the boot camp last week. We're really excited to get more involved with the DataEng Meetup community, especially with the conference coming up that we're going to sponsor and have a speaker and maybe even a workshop at. So stay tuned for that. And I think that's pretty much everything, everyone. So have a lovely night. You'll get a follow-up message from us. And so if you have any further questions, that's when you can respond, and we'll try and get back to you. Cheers.
See ya.
Good night, everyone.
See everybody.